is MoNaCo.
And Milks.
Unit 5, moles and stoichiometry.
Still doing it.
Yeah, we got a few videos left. We're going to record them all today. So on page 25 in your pack, we're going to go over some of the basic terms in chemical reactions, because this is the kind of the break in the unit. We've been doing all the little mechanics. Now we're going to see chemical reactions.
And dig into them.
And look at them and how the mechanics are related to them, so that we can always do this last process in the unit, which is predict the outcome of a chemical reaction.
We will get back to those tools that we've learned.
Yep,
Grand formula mass, moles, all that stuff is going to come back into play.
But we wanted to show you some of the symbols and nomenclature and notation you're going to see when you're looking at just any regular chemical equation.
Right. How about no math for a video?
No math in this video.
Right?
No math.
Right. All right, so first, chemical reaction.
It is represented by the arrow in the middle of the reaction. It is the process. A chemical reaction is the process by which atoms of substances are rearranged to form new substances. It's called a chemical change, and it's represented by that arrow separating the reactants on the left-hand side of the arrow from the products on the right-hand side.
There you go, and those are our next two terms. So the products are the substances that form as the result of a reaction. They're on the right-hand side. And then the reactants are the substances that exist before the reaction takes place. You could call them our ingredients, if you will. Reactants will react. They're on the left-hand side.
So the arrow is like a before and after. Before the arrow, we had these things. The arrow was the chemical reaction, the change. Then after the arrow, we got those things.
That's it.
There it is.
That'd be it.
So you will see lots of symbols in parentheses after chemical compounds listed. So like if I wrote NaCl parentheses with an S after it, I'm talking about the solid form of the sodium chloride.
Then it helps you as a chemist figure out what you're going to do.
Because as a chemist, I want to look at a chemical reaction written on paper
and almost know how to do it.
Imagine in my head what these things look like before and after I put them together.
Sure.
Yeah. So sometimes you're going to see a little cursive L after that.
Yep.
Means the chemical is a liquid.
Yep. And that one is usually cursive.
Yes.
But it's not like that Cl we have that problem with the element chlorine. We have the problem with that little L there.
This is usually in the cursives.
Yeah, and I think we're pretty good at always doing it cursive by hand.
Yes, for sure. And there's not many liquid chemicals out there that we handle except for water.
Yeah.
Maybe. That's about it. Yeah. We don't really handle gases too much either, but a G or a cursive G inside of parentheses after a compound is a gas. So
not to be confused with grams in this case.
Yeah, exactly. So
remember, these are states of matter that we're going to find.
Solid, liquid, gas.
And this is the biggest one.
Most common. And most definitely screws everybody up.
Yep. It means aqueous. Aqua is water. So aqueous is just in solution, but specifically water is the salt.
In water. So if I see NaCl with an AQ after it, I know in my mind it's water with salt dissolved in it.
Right. Not methanol, not ethanol, nothing, no other weird solution.
Water did the dissolving.
Right. Got it.
How's that for some alliteration? Wow. Go, bro. Now, these changes in heat are related to a specific reference table, which we'll do in kinetics, but most reactions do involve changes in heat.
They do, and we're going to dabble in them a little bit, maybe here or there, so we want to make sure we're covered just in case.
I will say every reaction involves a change in heat, just sometimes it's not detectable.
Right, or at least sometimes we don't really care about it.
Right, we don't care if it heats up or cools down.
Right.
Or if it does heat up or cool down, it's not that much. So
this unit we really don't. But we're going to throw it out there, let you get some, even if it's foreshadowing.
So every reaction has a heat associated with it, and the units for that heat are
kilojoules per mole.
Right, because chemical equations are always written out as mole ratios.
Right, and joules is that form of energy we're talking about.
And kilo means 1,000.
Right.
So 1,000 joules per mole. This is just units for the formation of and breaking down of chemicals.
And we did skip that funny word. It's called enthalpy. Delta H is enthalpy, the heat of reaction. Exo, we did this once before. Exo, the heat is exiting the system. In our cases, the delta H is going to be negative. The values, if I put a number to it.
And that has to do with the way that the heat is calculated. Results in a negative.
Always products minus reactants.
Yeah, the end minus the beginning, which gives us a negative value for something that got hot. Which seems a little odd in your head.
Yeah, we'll get into it deeper.
But heat left, so we put a negative.
Yep.
And then endothermic heat enters the system. The heat values would be positive. So it absorbs heat from the surroundings and overall.
Catalyst is a special substance that is going to, by definition, if it's present at the beginning, it needs to be present at the end.
And
it's not changed at all. It doesn't do anything except for what it does is it lowers this activation energy that we'll learn about later, provides a different pathway for the reaction, basically makes it go faster.
And you write this over the reaction arrow to show that it's not a reactant or a product, it's just part of making the arrow go.
Right.
It's like a shortcut. Like
Right.
you could walk over the mountain, you could walk around the mountain,
Or go right through it.
Catalyst lets you cut right through it.
Right. And we aren't even going to see these many times, but if you see something written over an arrow, because you want to get some more equations to practice balancing, you know what I mean, you might see something like that. So that's why we're throwing them in there, just to make sure you got it.
Mole coefficients. These are the numbers written before compounds in a reaction. They tell us how many moles are in the ratio of this compound to that compound makes these compounds over here.
Right. 2 of these plus 1 of these makes
4
of those.
Right.
Right, and they don't have to add up.
To
they don't have to
be the
equal.
same.
No, nothing. It's just they need to stay in that fixed ratio once it's balanced.
And you need to understand that the number in front of NaCl, like 4 NaCl, means there's 4 moles of NaCl that we're talking about.
Right.
Reaction. That's really
it really is what it means.
It means.
Yeah, it really does.
Cool. So
good. I think that's it.
that is it. And so you got to know some of these basic terms. I noticed last night when I was surfing around on our channel, the suggested videos next on the second half. Like when you're watching our videos, the suggested videos are awesome resources too.
Some of them.
Some of them.
Some of them were looked a little shady too, though.
Some of them do look a little shady. It depends on what you've been searching on your YouTube in the first place, kids.
Oh, it does?
It does.
I ain't been searching on shady.
No, but either way, if you don't understand anything that we do in our videos,
Where's the real Slim Shady?
he can please stand up. So if you're not understanding some of these terms, check out the suggested videos. Sometimes there are
you
really
might get lucky.
legit hits.
You might
For moles of stoichiometry, there was.
Oh, was there?
Oh, yeah.
Yeah,
Good
cool.
stuff. All right.
We're out of here.
Bye, everybody.